Hi friends, welcome to Curie Electronics. Today we are solving VSSC 2016 Electronics Technician B question paper. So up to 25 questions we have already solved. So today we'll see 26 to 50. All of you please press the like button and share the video. So let's start. Okay, question number 26. Which is true in a frequency modulated system? That is FM. Which is true in a frequency modulated system. Option A, variation of carrier amplitude does not affect quality of reception. Option B, amplitude of carrier is varied according to the modulating signal. In FM, carrier amplitude won't vary. The transmission does not require line of sight between transmitter and receiver. Option D, receiver uses diode detector. The answer is option A. Variation of carrier amplitude does not affect the quality of reception. That is why we use FM. Option A. Question number 27. How many bits are used in the data bus of 8051? This 8051 is known as 8-bit microcontroller. 8-bit microcontroller. So for a 8-bit microcontroller, the data bus has to be 8-bit. So the answer is option A, 8-bit. Similarly, 8086, it is a 16-bit controller. 16-bit, I think it's a 16-bit processor. So this data bus equal to 16-bit wide. Data bus 16-bit. 16-bit bus is used as data bus. So usually the controller processor known by its data bus, that is whether it is 8-bit or 16-bit. Question number 28. The output voltage of a typical thermocouple is. Thermocouple will give output in the range of. Thermocouple will output in the range of less than 100 millivolt. So using operational amplifier or instrumentation amplifier, we will amplify it. Thermocouple works on Seebeck effect. Seebeck effect. See, iron. There are some. See, thermocouples are different metal. At least two metals, combination of two metals. Normally, one type is iron constantan. Constantan. This is used to make thermocouple. Iron constantan. Iron constantan. Question number 28. A student was asked to connect 10 cells of 1.5 volt in series to make a battery of 15 volt. If one cell was connected in reverse by mistake, what will be the battery voltage? So in a series combination, one cell is connected reverse. So what is the? So we'll draw this or minus plus. Oh, sorry. So it's correct, but I want to. It's too big, I think. Okay, let me draw it. So how is your studies are going on? Are all of you are studying well? If you study well, future will be easy. Otherwise, you have to struggle again and again. So it's better to study. Okay, now we have 10 cells. 3, 4, 5. Sixth cell I will reverse it. Any cell you can reverse it. So this I will reverse it. This I have reversed. How many are there? 1, 2, 3, 4, 5, 6. Next is 7. 7, 8, 9, 10. Okay, now we have 10 cells. Now we will connect a multimeter here to read the voltage at this point. Here what is the voltage? This is V. This is minus, this is plus. Okay. Now, okay, now how many cells? All are 1.5 volt. All are 1.5 volt. 1.5 volt. So a student is connecting 10 batteries to make 15 volt. But one battery, this battery he has connected in reverse. So what is the voltage? That is the question. 1.5, 1.5, 1.5 volt, 1.5 volt. Now what I will do, I will write the Kirchhoff law. Kirchhoff's KVL I will apply. So I will go from here to I will go through the loop like this. Like this I will go. So that is the loop direction I am taking. Now if I go, I am going from here. Okay. So minus, I am going from higher potential to lower potential. So it is minus V plus 1.5 volt. Here I am going from lower potential to potential rise. So I will take plus 1.5, again plus 1.5, again plus 1.5. 1, 2, 3, fourth battery plus 1.5, plus 1.5. Sixth by 1, 2, 3, 4, 5. Sixth is minus potential fall. It's a potential fall minus 1.5. Again a potential rise 1.5. Again potential rise plus 1.5, plus 1.5, plus 1.5 equal to 0. Now how many 1.5 has to be there? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 are there. Now, see what happens? This minus 1.5 and this minus 1.5, we can cancel it. Correct. So how many 1.5s are left? 8 1.5s. So minus V plus 12 equal to 0. So what is V? V equal to 12 volt. So the answer is option C, 12 volt. Whenever we connect in a series combination one battery in reverse, you always have to take double of that voltage because these two, now these two batteries are in opposition. These two batteries are opposing. So these two will get cancelled. We will get effective output as the remaining voltage of the series combination of batteries. Okay guys. Okay, please if you have any doubt, please ask. If I make any mistake also, please comment it so that I will correct it. Okay. I will try my best to not to give any wrong answer. Still, there is always possibilities there. Question number 30. In the structure of a fiber optic cable, the refractive index of core is always dash the refractive index of cladding. This is always greater than. Core is always greater than the refractive index of cladding. So how do you remember? So it can always, see, normally when you take water, See, when light falls on water, what happens? Light falls on water, what happens? Light it water because you won't be able to understand my water. So now you see one light ray will be coming from here and it will pass through the critical angle, then happen some reflection it can happen. Okay, now you see you can remember this refractive index. This is air. Okay, refractive index of air equal to 1, but this water is more than 1. I don't know, I don't remember the value. More than 1, more than 1, maybe 1.3, something like that, I think. So you have the in the fiber optical case, you remember the same concept, that is cladding as air and the core as water. Then your answer won't go wrong. So always for the water or the core, always the refractivity is higher than the refractive index of cladding. Question number 31. In an LC oscillator, all of you know, it is consists of inductor and capacitor. The frequency, what is the frequency of an LC oscillator? Frequency is for an LC oscillator is given by 1 by 2 pi root LC. Root LC. So if you take proportionality, square root of LC is there. Frequency is square root of inverse square root. So the option C is the right answer. Inversely proportional to square root of L or C. So the answer is option C. So friends, we'll go to the next question. Question number 32. 30 question. No. 32. Question number 32. Sample and hold circuit in ADCs are designed to. See, sample and hold, you have to just remember there is a capacitor, something is coming, some signal or something is coming. We will place a capacitor, and capacitor will be there in the circuit. This will charge and hold that. It will charge. After that charge, usually we will use one op amp or something. Op amp we will use, then we will read it. If you are using interfacing with it, you can go to a microcontroller. So, what is the use of sample and hold circuit in ADCs? That is option A, sample and hold the output of binary counter during the conversion process. No. Stabilize the ADC threshold. No. It is option C. Option C is the correct answer. That is, stabilize the input analog signal during the conversion process. How does it stabilize? Using a capacitor it will store, and using one more operational amplifier we will take the output. Then we can sample it. Okay, let's go to question number 33. Maximum component density for a given PCB size can be obtained by. That means a PCB size is limited by using what kind of board, what kind of technology we can accommodate maximum number of components. Option A, leaded components and single-sided PCB. These are all technology now. Next, B, leaded components and double-sided PCB. Okay, leaded components and double-sided PCB. SMD components and double-sided PCB. SMD components and multi-layer PCB. And the right option is option D. That is multi-layer PCB. Nowadays, up to 20 layer, I think it is there. 20 layer also it is available now. 20 layer PCB. Okay, so why do we go for more layers? to make it compact. And when you work in higher frequencies, we need a minimum size. Okay, question number 34. A DC, a 10 volt DC source is connected to a series combination of 5 ohm resistor and 0. What will be the current through the circuit under steady state? Oh, we'll draw the circuit. That is 10 volt. I think it's a 5 ohm resistor. 5 ohm resistor and 1.1 microfarad capacitor. 0.1 microfarad, and this is 5 ohm 5 ohm resistor, and this is what the voltage, 10 volt. What will be the current through the circuit under steady state? Okay, now in a RC circuit, what will be the current at I as 0 plus, that is initially when powered on, at that power instant, what is the current? That equal to V by R. V by R. Okay. If you see here, in this case, this resistor is 0.5 ohm or 5 ohm, 0.5 ohm, I doubt. Okay, I'm not going to solve it. Next, what is at infinite time, the capacitor reaches steady state after 5 time periods, but after infinite time, after steady state, the capacitor draws almost zero current, no current at all. And I of at any time, at any given time, what is the current drawn by the capacitor? That is a maximum current, I max. Here it is V by R. I max multiplied by 1 minus e to the power minus t by RC. Okay, at any time we'll give this using this equation. At any instant we can find what is the current drawn by the capacitor. So as per this, what will be the current through the steady circuit under steady state? It is 0 amps. Question number 35. A 15 volt DC source is connected to the series combination of 4.7 microfarad and 10 microfarad capacitor. Which of the following statement is true? I'll draw the circuit. A 15 volt is a 15 volt DC source. It's 15 volt. And what is the combination of capacitors? 4 points. Oh, sorry. I should draw capacitor. Sometimes I don't know what happens to my brain. It goes somewhere. So I hope all of us are like that. Okay. Oh, this capacitor. Okay. You have two capacitors. Let me close the circuit. So this is 4.7 microfarad. This is 10 microfarad. And okay. Which of the following statement is true? Voltage across 4.7 microfarad will be more than the voltage across 10 microfarad. Voltage across 10 microfarad will be more than 4.7. So it is actually asking the voltage drop across the capacitor. No, first when you have a question like this, how we will go for it? We have to find C equivalent. That is 1 by C total equal to 1 by 4.7 plus 1 by 10 microfarad. So what do you get? It will come to 2.8 0.212 plus zero point 0.1, which equal to 0.312. 312. 312. Now what equal to CT? Equivalent resistance equal to 3.2 microfarad we'll get. One divided by, okay, now I'm not having a calculator. Okay, we'll 3.12 microfarad we'll get it. Microfarad. 1 second, hold on. Okay, we got 3 CT equal to 3.2 microfarad. Now, what is the once we know what is the total charge flowing through this, that is QT. We'll take it as QT. QT equals what? C equivalent multiplied by voltage we will give. So what we got here, C equivalent is 3.2 microfarad multiplied by 15. What comes? It comes to 48 microcoulomb. Okay, so 48 microcoulomb is passing through. 48 microcoulomb is a charge flowing through this series circuit. Now we have to find out what is the voltage drop across 4.7 microfarad and 10 microfarad. So across 4.7, how do you find out? We'll use Q equal to CV, capacitor equation. We want the voltage. So V equal to what? Q by C. What is Q? 48 microfarad. Correct? 48 microcoulomb divided by capacitance. Both are in same unit. So we need not to worry. So 3.2. So 48 divided by 3.2, what comes? It comes to okay, Q by CV. No, C. What is the capacitor value? You're the mistake. It's a mistake. Capacitor value equal to 4.7 microfarad. Okay, 4.7 microfarad. So it is 10 to the power minus 6. Here also 10 to the power minus 6 is there. So both will cancel. So 48 divided by 4.7. 4.7. It comes around 10. 10.2. So 10.2 volt is drop here. 10.2 volt drops here. Similarly, if we calculate, then definitely 4.8 volt should drop here. 4.8 volt. That also we'll just check it out. 4.82 volt should drop here. That is Q. Okay, we will directly Q. What is the Q? What is the Q? Total Q remains same. Both 48 into 10 to the power minus 6. What is the microfarad? 10 microfarad. Correct? 4.8 volt. So we got. Now we know what is the voltage drop across each. Okay. So from here you will understand if the capacitor value is low, then there we will have a higher voltage drop. So what is the answer? Now we'll see the options. The voltage across 4.7 microfarad will be more than the voltage drop across 10 microfarad. Equal. Charge on 10 microfarad will be more than the charge on no. So the answer is The first statement is correct. That is, voltage across 4.7 microfarad will be more than voltage across 10 microfarad. Guys, have you understood? You have to practice. Try yourself. Enjoy doing problems. Then they will solve it. The output of logic gate is 1 when all of its inputs are at logic 1. The gate is, what is the gate? The output of a logic gate is 1 when all of its inputs are logic. So we'll just write the AND gate. AND gate, what is a AND gate? Is a AND gate AB. If we take the, what is the truth table? A, B and Y is the output. Oh, sorry, I should not have drawn like this. 0, 0, 0, 1, 1, 0, 1, 1. In AND gate, we will get output. All the output of a logic gate is 1. Oh, his question is output is logic gating is 1 when all its inputs are at logic 1. So this is for AND gate, it is true. Which is the other gate? So we'll take OR gate. So OR gate, what happens? A, B, Y. A, B, Y. 0, 0, 0, 1, 1, 0, 1, 1. See, do you know what this follows? It follows a gray code. The 0, 0, 0, 1, 1, 0, 1, 1. This is follows the gray code only, but one bit will change. So 0, 0 will give 0 only. 0, 1 will give 1. 1 also. This also follows whenever both the output of logic gate is 1 when all its inputs are at logic 1. At logic 1. Here also we are getting it. Now we'll stay, okay, we got AND gate, we got the output of a logic gate is 1 when all its inputs are at logic 1. Its AND gate option is there. So it is either, AND is correct. So it is either or NOR. Or we got. If we just take a Y complement, what will come? We will get for NOR, okay? For NOR AB 0, 0, 0, 1, 1, 0, 1, 1. For NOR, both inputs are 1, you will get remaining all you will get 0. So we will go with the option B, and OR gate. Okay, the output of logic gate is 1 when all of its inputs are logic gate. The gate is either AND or OR. Now question number 37. The most suitable gate to check whether the number of ones in a digital word is even or odd is. We use XOR gate for parity check. That is even parity and odd parity. Okay, what is the truth table of XOR gate? First we'll draw the symbol. This is a XOR gate. A, B and Y is the output. If I write the truth table, A, B and Y, 0, 0, 0, 1, 1, 0, 1, 1. For an XOR gate, whenever the inputs are different, that means both the inputs, that is A and B, should not be same. Then only the output will be high. This will be 0, this will be 1. Okay. So whenever odd parity comes, it gives output 1. So it can be used to detect odd parity. So the answer is option A, XOR gate. Question number 38. Find out the effective resistance between A and B. So I hope all of you are familiar with these kind of simple questions. So if we see, these two are in parallel. 3 ohm parallel with or 6 ohm. So if we solve this, what you will get? 3 multiplied by 6 upon 3 plus 6, that is 18 upon 9, which comes to 2 ohms. So now I'll redraw the circuit, that is 2 ohms in series with 18 ohm, which is parallel with 5 ohm. Again one more 8 ohm resistor is there, 8 ohm. This is 5 ohm. This is B. This end is A. Now 2 plus 18, so we will get, again we can simplify as 20 ohm resistor, 20 ohm in parallel with 5 ohm. 5 ohm which is in series with 8 ohm resistor, 8 ohm. So this is B, this is A. Now 20 and 5 ohm, 20 ohm parallel with 5 ohm. What we get? We get 20 multiplied by 5 upon 20 plus 5. It comes to 4 ohm. So 4 ohm series with 8 ohm. 4 ohm series with 8 ohm. That is A and B, between A and B. So answer is, we can replace by a single resistor between A and B, that is 12 ohm resistor. So the answer is option D, 12 ohm. Question number 39. Which of the statement is true? For this we have to write the Kirchhoff voltage equation. So he is taking the clockwise. We are moving clockwise. So V1, I am starting from here. So it's a rise in potential. That is V1 plus I R1 plus I R2, because I am moving in the same direction of current, plus I R3 minus, from here I am going, so it is fall in potential, that is minus V2 equal to 0. Now we have to relate with this one of the equations. Now V2, okay, V2 equation we have, so we'll try to equate with V2. V1 also there. V1, if we try to equate, what we will get? V1 was V1 plus V2. What we get? We won't get V1 plus V2, because this is a rise in potential, this is a fall in potential, so we won't get it. So what we'll write, I'll write what is V1. V1 equal to V2 minus I R1 plus R2 plus R3. Do we have any equation like this? V1 equals V2. Yes, we have. No, we don't have. This is minus V2. This is minus V2. This minus V1 equal to what will get? V2 minus I1, R1, R2, R3. If I take V2, if I write for V2, what I'll get? V2 equals V1 minus V2, I will take the other side, I will get all plus I will get. Okay, it's not coming. Let's try. V1 plus V2. V1 plus V2 we can write. See, I am applying the case KVL. Minus V1, it is V1 plus R1 plus R2 plus R3 minus V2 minus V2. Question number 39. Which of the statement is true? Okay, this I will apply KVL in a anti-clockwise direction. KVL, Kirchhoff voltage law. So I am starting from negative. So I will always take the starting point. Minus V1 plus current direction is same. So plus IR1 plus IR2 plus IR3 plus V2 equals 0. Now I will arrange for V2. What is V2? V2 equals V1 minus IR1 minus IR2 minus IR3. So the answer is option C. See, that is perfectly following the Kirchhoff's law. I'm starting from the negative terminal of the battery. So I'm always writing the negative from where I am going. That is negative V1 plus current through R1, R2, R3 are in the same direction as the loop direction. So all are plus. Plus the last V2 I am going from plus to minus. So I'll write plus V2. Now V2 equal to V1 minus of this. So it is there the option C. Answer is option C. Question number question number 40. Which of the statement is true? So we have a circuit here and two current sources are there. Okay. Now the first statement is V1 in volts. Okay, this voltage V1 in volts. So what is there? That is I1. This is a current source. It's I1 in parallel with 500 ohm. 500 ohm. This is I1. This can be replaced. This can be replaced by a current source, a voltage source. So how do you replace? V equal to IR. I into R, that is I1 500. Okay, so how do you replace? We can replace it with a plus minus, that is I1 500. There will be a 500 ohm resistor, 500 ohm resistor. So this part I have replaced. Now what is the voltage here? This is going to be same voltage will be here, that is I1 500. So the answer is option A. V1 in volts equal to, the other one will be option, what is option B? V1 in volts divided by 500, and so many things. I think not V1, V2, V3 are independent of I1, I2. It can't be V3 in volts. So this is the correct answer because it's a source transformation. Source, this current source we will transfer to a voltage source. That voltage source is equal to I1 into 500 amps. There is a series resistance also. When you place at this point, we will get I1 ampere into 500 ohms. Question number 41. The ripple frequency of a full wave bridge rectifier working with 230 volt, 50 Hz, AC means is 100 Hz. Which of the statement is not true? Full wave bridge rectifier, for full wave rectifier, full wave, 2 times the F out. F out equal to 2 times F in. For half wave, F out equal to F in. For the ripple frequency, this is for ripple frequency. Now we will see the which of the statement is not true. Option A, the ripple frequency of a half wave rectifier working with the same line is 50 Hz. The ripple frequency of a half wave rectifier working with the same line is true. Option A is true. Option B, the ripple frequency of a full wave center tapped rectifier working with the same line is 200 Hz. No, this is wrong. The ripple frequency of full wave center tapped rectifier working with the same line is 100 Hz. This is true. So the answer is option B is the wrong statement. Question number 42. The given combinatorial circuit can be replaced with, this is inverted. This is inverted. This gate is like this. This is an inverted OR gate. Bubbled OR gate. We'll say bubbled OR gate. Bubbled OR gate is equal to a NAND gate. NAND gate. Okay. Bubbled OR gate is equal to a NAND gate. So the answer is option C. Answer is option C. We can write the truth table also. So what is the A and A, B, A, B, A complement, B complement, output. Now 0, 0, 0, 1, 1, 0, 1. These are the A we are giving, but it get complemented here. 1, 0, 0, 1, 0, 1, 0, 0. Now, so this is the input to the OR gate. OR gate, whenever any of the inputs are 1, output equal to 1. Okay. Now we'll write the NAND gate truth table. What is the NAND gate truth table? A, B, Y. A, B, Y is the output. 0, 0, 0, 1, 1, 0, 1, 1. Because it's just opposite to AND gate. So Both the truth tables are matching. So this bubbled OR gate is equivalent to a NAND gate. Question number 42. Hi guys, are you getting bored? Bored? We can't say because we have to clear our exam. We have to clear our exam within 20 rank, not more than that. Okay, so we'll now what is the color code of 220 ohm resistor? 220 ohm resistor, what is the color code? That is red. First two digit for the first two color for digit. Third is the multiplier. What is the multiplier? Into 10. What is 10? 10 is brown. So it is red, brown. Red, brown, gold. Gold is for 5%. Red, 2 multiplied by 10, 220 ohm resistor. Question number 44. What type of switch is this? This is a single pole. This is the pole double throw. Single pole double throw switch. Answer is simple single pole double throw. SPDT. 45. Question number 45. Which voltage source convert chemical energy into electrical energy? That everybody knows. Battery converts chemical energy to electrical energy. What is the efficiency of solar cell? Efficiency of solar cell. Efficiency equal to 10 to 15%, not more than that. Within 10 to 15%. Okay. Question number 46. Question number 46. If a 40 coulomb of charge flow past a point in 20 seconds, what is the current? What is I? I equal to dq by dt. dq by dt. Both they are given. That is q by t they are given. What is q? Q equal to 40 coulomb past a point in 20 seconds. So what is the current? 2 amps of current is passing through that point. That is option A. Question number 47. When parallel resistors are of three different values, which has the greatest power dissipation? The lowest resistance, that is the least resistance will have the maximum power loss. Maximum power loss. When but the smallest resistance, the largest resistance, they have same power loss. Not at all possible. The voltage and resistance values are needed now. The smallest resistance will have the greatest power dissipation. Question number 48. What is the total power loss if 2K and 1K parallel connected resistors have a total current of 3 milliamps? We have to find the current. Now, so I will convert this to resistors to ohms. That is one is. Now we will keep it like this. To solve this the parallel combination, we will keep it as 2 and 1 kilo ohm only. This is 1 kilo ohm, 2 kilo ohm and 1 kilo ohm. That comes to effective resistance RT equals to 2 multiplied by upon 2 plus 1. That is 2 by 3. That equal to 0.6666 it comes. So if we, that is in kilo ohm. If we convert to ohm, what happens? It will be 666 ohms. We can round it up to 666 ohms. Now, what is I has given us 0.6666. 3 milliamps, which equal to 0.003 amps. Now both are in same unit. Now what we'll do? What is power? I square R, which equal to 0.003 whole square multiplied by 666. We'll take it 666. That is what we can write it as 0.003 multiplied by 0.003 multiplied by 666. Now what I will do, what I will take out 3 multiplied by 10 to the power minus 3. Again 3 multiplied by 10 to the power minus 3 multiplied by 666. Now if we multiply, what we get? 3 multiplied by 666, what we'll get? We'll get nearly 2000. 2000. 9 multiplied by, no, here, no, not 3, it's 9, no, it's 9. That is 9. So we'll get 9 multiplied by 666. The correct this I can write it as 10 to the power minus 3 multiplied by 10 to the power minus 3 into 9 multiplied by 66, which equal to 9 multiplied by 66, 5.9994 we will get. 5.994 we will get. 5.994 multiplied by 10 to the power minus 3 into 10 to the power minus 3 will come. If I shift one point here, this can be written as 5.994 into 10 to the power minus 3. If you round it to 6, it will be 6 into 10 to the power minus 3, which is equal to 6 milliwatt. Answer is 6 milliwatt. You should know the exam, you should not take so much time. Okay, so we'll go to the next question. Number 49. What is this circuit? The circuit is given. Okay, we will find what is the time constant of the circuit. That is RC equal to tau. Tau is the time constant. What is the value of RC? Tau equal to 1 microfarad, 1 into 10 to the power minus 6 multiplied by 1 kilo ohm, 10 to the power 3. So we will get 1, what we will get? 1 into 10 to the power minus 3. That equal to 1 millisecond. 1 millisecond we got. This is the time period of the circuit. Now what is the time period of the signal? Tau of signal is equal to 1 by 1000. That is 1 into 10 to the power minus 3. This is also 1 millisecond. From this time period, we can understand that, see, this will what, if you look at the circuit, what happens? It will pass the high frequency, but it won't pass the low frequency because the capacitor is there. Capacitor will provide infinite resistance for DC. The capacitor provides infinite resistance for DC. So it won't pass low DC. So it's a high pass filter. And only doubt we could get is whether it is a filter or differentiator. But if we see the time period of tau of signal equal to tau of circuit, RC circuit. So it's a high pass filter. Answer is option B, high pass filter. Now we can find the cutoff frequency of this high pass filter using 1 pi 2 pi RC equation. 1 by 2 pi RC equation. Now, when the circuit becomes a differentiator, signal, the signal time period should be much smaller than the circuit tau. Then only this circuit becomes a differentiator. So we'll go to the next question. Question number 50. Which of the following, friends, this is the last question. So all of you please like the video and share with your friends so that I will keep on updating more videos for you. So the question number 50. Which of the following determines the capacitance of a capacitor? Capacitance of a capacitor C equal to A epsilon naught divided by D. So it is the area distance between the plates, plate area, plate separation, and the dielectric constant. This is the dielectric constant. So the answer is option D. So friends, thank you for watching. See you soon with the third part. Thank you. Take care.